Oh, hello everyone. I'm Arvind Sukumar. I'm an engineer in NEC working on the ProgrammableFlow product line. So today I have two parts of the demo. The first part is going to be about the system center integration of our NEC's ProgrammableFlow controller. And the next part of the demo would include the service chaining, which we will go once we are done with this. All right. So NEC has worked with the Microsoft System Center, and they have created a software which will be installed on the System Center Virtual Machine Manager. And this software will initiate an API call to the PFCs or the Programmable Flow controller. And if there is any network change from the SCVMM or the System Center, that will trigger an API message to the Programmable Flow controller, which in turn will make some changes on the virtual tenant network, which is called VTN. All right. Now, let me, before we get into the demo, I would like to give a brief introduction about what a virtual tenant network means. So a VTN, standing for Virtual Tenant Network, it's nothing but it's an abstraction over the physical layer. So we can, it is a logical layer representation. So we can now create the networks or modify or manage the networks from the logical layer instead of doing the device level configuration. So the device level configuration has now been abstracted into a logical entity, which is centrally managed and controlled from a VTN. And this VTN is inside the PFC. So that's how the network is being driven. So how to create a VTN? So there are several ways. There are a few ways actually. So one is using the web API. We have an open REST API through which an application can configure or modify a VTN. The second way is by using the CLI. So you can log into the PFC. We have a shell called PFC shell. It runs on a Linux environment. So log into the PFC shell and then you can create a VTN. And the third way is by using the web UI. So we have a web-based UI which is capable through which we can create a network, modify a network, and also it also helps in visualizing the current network statistics. So now I've just created a new virtual tenant network, and then inside the virtual tenant network we have some virtual components which are called virtual bridge and the virtual router. So if you want to have a layer 2 connectivity, you can just create a layer 2 vBridge, and then you will be having a layer 2 access. If you have multiple layer 2 and if you need a layer 3 connectivity between them, then you will go ahead and configure a virtual router. So this router is capable of handing over the package from subnet between multiple subnets. So this is how you will create some virtual components inside the VTN. Then, after we create the virtual components, we need to attach the host devices into the VTN. So how do we attach the host devices to the VTN? The host can be a server, a VM, or a legacy router, or a switch. It can be any of the non-open flow devices. So how can I connect a legacy or non-open flow device to this VTN, which is capable of doing the open flow? So the first there are three techniques. So the first technique is using the interface mapping. So interface mapping is by using the physical port of the switch, the open flow switch. So using the physical port of the open flow switch and configuring it inside the VTN. So this is one way of connecting a host to the VTN. The second way is using the MAC address, the actual MAC address of the host. So you can configure the MAC address of the host inside the VTN. This way, you can have any traffic from that host to be connecting to that particular VTN. And the third way is by using the Vlan mapping technique. So the Vlan mapping technique is it's a dynamic way of representing or connecting the host to the VTN. So in this case, the host will be tagging a Vlan ID to the package that they are sending into the network. So based on the tag information, the controller will be able to connect the host to the appropriate VTN. So these are the three ways that we can represent and represent a VTN or create a VTN and connect the end devices into the network.
Just a couple of questions coming in on the Twitters. What are you seeing for what scale of VTN production deployments and stuff are you seeing in terms of numbers of nodes? So what's the sort of scales that sizes that people are doing right now?
So we can go up to 1,000 VTNs per controller.
And are you seeing people starting, deploying significant size?
Yes, I believe. So there are multiple ways of defining or creating or deploying a VTN. So there is a use case where there are about 10 VTNs created in the hospital use case that Toshal described. In that hospital use case, there are multiple tenants created for each subscribers. So, for example, a doctor needs to have access to the file server, which should not get access for the public. So there is a VTN created for public. So public can connect to the Wi-Fi, and the doctors can connect to another Wi-Fi. So this way, the VTN gives them a separation. It isolates the traffic, so the host connecting to that VTN can only communicate within those servers.
And sort of in the number of, I guess, like endpoints and devices across the fabric, what sort of?
We can go up to 1 million endpoints per controller. I mean, so the controller is the OpenFlow based controller, which is going to manage the switches underlying OpenFlow switches. We have another product called the Unified Network Coordinator, which we were introduced, right? So the UNC is managing the controller. So a UNC can manage up to 10 different controllers. Geographically, it can be located anywhere as long as they have a connectivity. So the UNC manages up to 10 controllers, and each controller can manage 200 switches and 1 million endpoints. So this gives you up to 10 million endpoints that can be managed from a UNC, the coordinator. Any more questions?
Matt is also interested in knowing about if you're putting in place any mechanisms beyond OpenFlow to help with scalability and limiting failure domains.
So the UNC, I guess, would be one of them, right? Yeah. You're building a hierarchy through that UNC, right? So the UNC only can manage 10 controllers?
Right now, they can do up to 10 controllers. I believe the work is going on in developing to add more.
Because I'm the failure domain associated with a controller that has 2,000 switches and 1 million endpoints is rather large. So
the controller can manage 200 switches.
Did I say 200 switches and you said 1 million hosts, though?
Yeah, 1 million hosts. 1 million MAC addresses.
Endpoints or clients or whatever, I guess. So
how do you get
devices?
It's a whole lot. You have to have a whole lot of wireless coverage or something because there's not that many ports and 200 switches. VMs, oh yeah, I guess you're right. Yes.
So you can do a VM or the mobile devices, all these can be a part of this.
Okay, yeah.
So what's the biggest one you've actually built?
Sorry?
What's the biggest one? These are theoretical numbers. What's the biggest SDN-controlled network you've built?
Well, NTT is deployed in production. Their enterprise cloud based on ProgrammableFlow.
And do you have numbers for that?
They've deployed in 11 data centers in 9 countries worldwide.
All right, shall I move on? Okay, so now since we know what a VTN is and how to create a VTN, let's look at the integration part of our controller with the Microsoft System Center. So, as I described earlier, NEC has created a plugin which is called a VSEM provider. So it is a plugin which will be installed inside the System Center Manager. So this VSEM provider, which stands for Virtual Switch Extension Manager. So this extension manager will be tightly coupled with the System Center's Network Manager. So whenever there is a new network created on the System Center, that will trigger an API call to the controller using this VSEM provider, VSEM extension. All right, so this is for the virtual network. And also, if you have a new Hyper-V host that you are connecting to the System Center, then the System Center will also provision the PF1000. PF1000 is the virtual switch extension for the Hyper-V virtual switch. So PF1000 is the virtual switch which sits on each host, and the system center is going to manage all the hosts, and the controller is going to manage the network. So this way, the network virtualization can also be a part of the server virtualization, which is now getting you an added benefit for managing the networks from a single point. All right, so this is the vSIM provider, which I described. And whenever you have a new virtual switch created on the system center, whenever you have a new virtual switch created on the system center, that will initiate the PF1000 virtual switches to be deployed on the Hyper-V hosts. All right?
When you said when you create a new system in System Center, it triggers an API call?
Okay.
Or do I have this backwards?
The Hyper-V.
Okay.
So, assuming you have an existing environment and infrastructure, and you have a new Hyper-V host coming up,
okay.
Then when you create a virtual switch for that Hyper-V host, the SCVMM will deploy the PF1000 extension on that new Hyper-V host. So that was what I meant.
So, so does that go towards your 200? So that still goes to the controller. Is each virtual switch PF1000 count as a switch in the controller?
It is also a part of the controller's 200 switches.
Okay.
All right, once we have the PF1000, which is a virtual switch extension installed on the Hyper-V host, now we can now start creating the VM network from the system center. So VM network is the part of system center where you create a new network and add some host into the network. So when you create a new VM network, this will initiate an API call to the ProgrammableFlow controller through the vSIM plugin. And that creates, the SCVMM actually creates a VTN on the PSC, which is the ProgrammableFlow controller. All right, then inside the VM network, we have an option to create multiple subnets. So for each subnet that is being created under the VM network, an API call is again established to the ProgrammableFlow controller, which creates a virtual bridge. If you remember, I said virtual bridge is created to handle a single broadcast or a single subnet domain. All right, now, third, whenever we have a bunch of VMs, now we can from the System Center console or the GUI, we can now add or attach the VMs to the appropriate VM networks. So this way, the VMs will be connecting to the appropriate VM network, and internally it will also be connecting to the appropriate VTN. Is that clear? All right. Once we have the VMs deployed and also connected to the VM network, then we can have an active traffic established between the two VMs. Now, what happens if you move the VM or migrate a VM from host A to host B? In that case, the VTN is still the same. We are not changing the VTN. We are just changing the location of the virtual machine. So since the VTN is going to be managed logically, all the underlying switches are just going to send a packet in, a new packet in from a different host. It doesn't matter. It is going to come with a VLAN ID or a MAC or one of the interfaces that we configured, the vExternal. Depending on the information, the packet in message that the controller receives, it's going to tie it to that particular VTN. So this way, VM migration has become more easier in deploying. So if you have some a requirement to move the VM, we don't have to make any changes on the network. All right, so now we saw the picture presentation of our system center. Let's go into the live demo where I will show how the system center and the control integration works. So this is the GUI of the system center virtual machine manager, and I have a set of virtual machines created to generate traffic. And then inside the VM networks, I'm going to just go ahead and create a new network, and I'm going to give it a name. I just named it tenant B. So I'm going to now add the subnets. I'm going to add one subnet for now. So I'm going to give it a subnet range. And then now, okay, so this one says a job has been completed. Now let's go into the programmable flow controller UI. So this is a web UI of the programmable flow controller. So here we can visualize the traffic, we can visualize the switches connected to the controller, and also visualize I'll also make some changes on the network as required. Now I'm going to get into showing the new VTN that has been created. It has also created a new virtual bridge under it. Now, just to show how it works, let me first generate a traffic from VM5 to VM3. Before getting into this, I would like to give you a system overview that gives you about So this is the environment that I have set up for the demo. So we have a system center manager, programmable flow controller, and I have two Hyper-V hosts where there are a bunch of VMs running on it. And I have also integrated with the Dell OpenFlow switch, which is a S series 4810 switch. And I have a 1 gig uplink for each Hyper-V host. So my first goal would be to generate a packet from VM5 to the VM3, which are belonging to the same subnet. Okay, and the next part would be generating a packet from VM1 to VM2, which are also belonging to the same subnet. But the good point to understand here is VM5 and VM1 are having the same IP address. But what I'm doing is I'm connecting them to a separate or different VTNs or VM network. So this way we can have an isolation on the VTNs, which gives you an advantage of duplicating IP addresses. All right, going back to the demo. Currently, this VM is not connected to any VM network because we just created the VM network. Let me generate a ping to the VM3. Absolutely it will not work. I can also generate a traffic from the VM3 to 10.10.10.1. Oh.
Any chance you can make that font a little bigger?
So I'm using the viewer from the system center, and this does not allow me to make any changes on that.
No is an acceptable answer.
It's Microsoft's fault.
I think it was good to know type rather than what.
Have a beer.
All right, now let me connect the VMs. Let's say this is VM3. I'm going to connect this VM to the VM network that we created. So BB1 and the new subnet called sub1 that we created, and I'm going to attach it there. And I need to connect the VM5 as well to the same VM network. So after this network, the job status, once it gets completed, you will see that there is a traffic which is being, so now we have an active traffic between the VM5 and VM3 generated. Now, let's go into the GUI console, and I would like to show, how the web UI can be helpful in visualizing the active traffic flow. So this way it says there is a VM, there are two VMs which are connecting to this subnet, and they have an active communication. So these are actually the flow rules that are set up on the open flow switches. So based on the flow rules, we are able to view what is being set on the switches. And this is a VTN view. We also have a physical view of the topology. So this is a physical view of the topology. We have 4 switches that I described on the system overview. So we have 4 open flow switches which are connected to our programmable flow controller. And all these 4 switches, I mean all the PFVS is the virtual switch which is on the Hyper-V host, and these are the Dell switches. So we can now visualize the traffic across the physical topology. So we can see that there is a traffic from VM3 to VM5, and we can see which link and which path it takes for the traffic to go across the physical network. So this gives us a visibility of the traffic across the network, the live traffic. Now, let me ping from VM1 to VM2, like I said. So VM1 is also has the same IP as VM5, but there is no problem in duplicating the IP address as long as the VTNs are different. So if I refresh this page, you will be able to see the 2 new flows that are being created. So the traffic between VM1 and VM2, they belong to the same host, so there is no traffic going across the network. Now, the next point would be, okay, we have created a layer 2. Let me create another layer 2 or a vBridge on the system center on the new VM network. Add another subnet to the newly created VM network. And I'm going to show how the routing can also be configured from the programmable flow controller. So now I just added another subnet called sub2, and once you go into the VTN, you will be able to see the new subnet that's being created. A new vBridge is created. Now I'm going to attach a host, a VM that is having the IP address on 20 subnet. So that is VM6. It's connecting to sub2, it's fine. Now I'm going to initiate a communication from VM6. 10, 10, 10, 1. We know that 10, 10, 10, 1 is a part of the VM network. All right, we don't see a communication yet because we don't have a virtual router created on the VTN. Now let's go ahead and create a virtual router from the web UI. I want to show how to, yes.
So I was just going to say, this is sort of a tangent, but just a question and comment came up on Twitter that your topology view is quite nice, and it would be really cool if there was like an export to Visio XML option for that.
Okay.
Noted.
Not yet.
Good answer.
All right. I'm going to show how we can create a VTN or modify a VTN from the web UI. All right. So here we need to get into the configuration mode of the web UI console. And then we have an edit tab where we have the options of the virtual components called vRouter, vBridge, and vExternal. Now all we have to do is drag and drop a virtual router. I'm just moving this for our. All right. And between the virtual router and the virtual bridge, we need to create a virtual link. So this link is going to connect the vBridge to a virtual router. Now that I have created this, the VTN, now I'm going to save this. What is the next part? The next part is this virtual router should act as a gateway. So currently these guys are belonging to different subnets and they don't have a gateway point to reach out to the different subnet. So now I need to configure the virtual router to handle the traffic, right? So I have two interfaces on the virtual. This is very similar to a physical network. So this virtual router has an interface and where you configure the IP address. So now let me go ahead and change it.
So you're doing virtual patching and then addressing the ports.
Sorry?
You ran a virtual patch cable and now you're putting addresses on it.
Yes, exactly. I'm going to change and add the other one. So to 20.20.20.0. So I thought there would be a question about how I knew which subnet the interface belongs to. Okay, anyway. So here, this part of on this window, you can see that the sub 1, which means a vBridge 1, is being connected to that interface. So this will give us an idea which subnet we are going to configure at that moment. So this is another advantage of using this web UI. All right, change. Now let me go ahead and save this. All right. Now I have saved. Let's go into 6. Now we see that there is an active traffic established between different subnets. So this way, it's very easy to configure a vRouter, which we saw. We don't have to go out to an external router to have a route between multiple racks or other things. It can all happen to be, it can all stay within the OpenFlow domain switches.
So just one thing on the workflow around making a change there. So I'm going to put this IP address in here, this IP address in here. You then go and commit it at the point that you save it.
Yes.
Is there any rollback type functionality?
Rollback type, before you save, probably you can delete it. But after you save, we don't have it. We have to remove it.
You know what I mean? I basically, let's say I've lined up 5 things and I hit save and then I go, ooh, that wasn't good.
Network went down.
And so I've got to know what to
Like
get
a commit
back to,
confirm
not rather
type of
than doing a
function.
revert.
There is no revert function after we commit because the committing. So there are 3 storage containers basically. So like we have on a legacy switch or any switch, we have a running config and a startup config. Here we have included another config called a candidate config. So whenever you make some changes on the VTN, it gets stored on the candidate config. That is the time when you want to make some changes on the configuration. So when you make the changes, when you make some new changes, you will be able to see what changes you made on the candidate config. And once you confirm, okay, this is the configuration I want to put in, then you can put it into the running config container. But and on the other hand, if you think that, okay, I made a mistake, then you can do an abort function and that will delete the candidate config, whatever you newly configured on the system.
So there are some separate stages through there that I can,
Yes.
So after it's committed, you can do what was the term that you used?
revert the
Remove or whatever, and that essentially rolls it back to the original config before the candidate config?
No. So candidate config gives you an option to abort, which means revert.
Right.
Running config does not give you an option to go back to candidate. It is a one-way traffic.
Okay. So just as a suggestion, you've already got the candidate config in place. It seems like a very small step forward to add the functionality to roll it back, because the candidate config is the hard part.
Yeah, just because, we've all screwed up changes in the past. And we should have all backups and everything. It should all be there, but life happens sometimes.
Yeah.
Okay, I will take that. I'll note that down. Let me check.
I mean,
timeline. Go back in the timeline.
Yeah,
right. I mean, you already did the hard part, right? You have the
That's a good
candidate
point.
config stuff in place. The hard part's already finished.
Yeah.
So it's basically, what do you call it?
I guess if you've got a good audit log
the
and whatever
version-
anyway, then you're pretty much, you can see what's going through.
You have a timeline.
Yeah.
Go back and click on
Well,
that date and that's it.
I mean, it's even it's more simple than that. I mean, it's just simple version control, really.
Yeah.
Of course, I don't have to code it, so I can say it's simple.
It's easy to wave our arms around.
Right? Yeah.
So the layer 3,
Yes.
the virtual router, is this, I'm kind of assuming that it is effectively fully distributed.
It's distributed across the OpenFlow network that is managed by that controller.
Right, so it's not, that virtual router is not located any one place, because so between two subnets on the same switch,
Yes.
it's going to go direct and not have to go somewhere else and come back.
Very true, very true.
Okay.
Yes, that's exactly how it works. So even if you have 200 switches, and if you have a virtual router and the connections has to be between the switch 1 and the switch 200, you still have just a V router. The path taken in between is all managed by the controller by doing it does a topology discovery initially. I will get into that once I'm done with this.
Sure.
All right, so we now know how the layer 3 stuff works. Now, let me get into another part of the physical topology. All right, so this is the physical topology view, like I said, from the controller. So what we can see from this topology is the green lines that you see in the topology or in the view are automatically generated by the controller. So when you have an open flow switch connected to the controller detects if the switch has any up interface, and if it has an up interface, it sends a message, an LLDP type message with no load, it's just LLDP, and then it sends out through the neighboring interface, through this interface to the neighboring switch, and this switch will send a packet into the controller, and the controller detects there is a link between the two switches, and that's how it draws the topology. Now, let me give you a live presentation of removing one of the links from the switch. Interface.
This is one of the Dell switches.
The Dell switches, yes. Okay, I just shut down the port on one of the switches. Now I got to refresh. Now you see that the link is gone from the view here. So this shows that the controller manages the physical topology information, and it also draws on the view here that we see. Let me bring that guy back.
So you're using Dell switches as the physical switches.
Yeah. Dell switches are the physical switches.
And the edge switch is actually the PF1000.
Yes.
So the actual flow data is on PF1000, and the Dell switch just has layer 2 forwarding entries.
Yes.
Thank you.
All right. So now we understand how the physical topology is automatically generated by the controller.
That brings up another question. So between the PF1000 and your Dell switches, are you doing MLAG? Is that layer 2 MLAG?
No, it's just...
so you're actually controlling the 4810s then with the controller?
Yes. The controller manages or controls.
Just now when you did the CLI, you went straight to the switch and did a shut down and a no shut?
Yes.
So you just you bypassed the controller for that?
No, we don't bypass. Whenever there is a change on the switch, like an interface going down, it sends an information to the controller, and controller removes that entry from the switch.
Okay. So you just bypassed you SSH directly that you still had the ability to do that in that device.
We can do it from the switch, or we can also do it from the controller.
Okay. All right.
From the controller, we can manage the switch interfaces. We can do the admin state up and down.
We could go into there and go, okay, well, that other link, I'm going to shut that one down as well.
How do you do that? Which protocol do you use?
We use an open flow message to shut down the port on the switches. So the controller will not actually shut down the port on the switch. The controller will assume or it will confirm that this port should not be used.
Okay, that's a different story. That's not shut down.
Stop porting.
Oh, okay. There we go.
Not the physical
Yeah, but there's no light loss.
No.
Okay.
No, there won't be a light loss. It is the admin state up and down.
Yeah.
Okay, that clarifies. Okay.
All right. With this, we are done with the first part of our demo. We now know how the system center integration vRouter thing works. Now let's go into the service chaining. So the service chaining is nothing but stitching in multiple services in line between the client and the server. So before reaching the server, the client has to pass through multiple services like a firewall or a DPI or a DDoS mitigation system. So all these things are considered to be a service in this case. So beginning with, I'm going to create a first redirect filter. So this is also configured inside the VTN. So inside the VTN, I'm going to set up a rule or a policy that says matching on this destination IP or matching on this source IP or a combination of dest source IP, push the traffic out through this interface on the switch. Is that clear? So that is possible to be done from the VTN. So how I'm going to do that? For the demo purpose, I have the script ready. So I'm going to run the script. And before that, let me generate traffic from VM1 to I'm going to ping 20, 20, 24. Okay, so 20, 20, 24 belongs to a VTN, and it's called VM4 in our demo system. And I'm also, side by, I'm going to generate another traffic from VM2 to the same server. So VM1 and VM2 are talking to the same server, which is VM4. All right, we see the traffic going through, and currently there are no services inserted. Now I'm going to go ahead and insert a service. And for this service insertion, I'm going to use a CLI. So this is the CLI of our controller. It's a Linux machine, and inside you have the PFC shell command, which lets you log into the controller console. And inside the controller console, you can do show running config, similar to the switch things that we do. So this will give you all the details about the VTN configuration. And show candidate config. So once you show candidate config, if you have any changes, you will be able to visualize the candidate changes. That's for your information.
Will that show me, when you do show candidate config, is that the whole config, or is that just, you know, just the delta to be applied, or can I see the delta?
You will probably see everything, but you will see there is a, I mean, these are actually the running config output. Yep. If you see a candidate config, let me do something.
Yeah, like could you just, yeah, like, you know, make a little change.
I'll create a new VTN.
How it highlights it or whatever.
I'll just create a VTN called test.
Yeah.
So this indicates, the star before the conf indicates there is a new configuration.
Ready to go.
Do you want to change or abort, right? So now if I do a show candidate config, you will see there is a new VTN called test available here.
Yeah.
Now, if you want to remove this, just do an abort, and now the VTN called test is gone. So this is a place where you can make some changes to your network before committing it. All right, here, let me run the script, and before, let me give you the graphical view once again. Sorry. All right, I have a layer 3 traffic going from VM1 to VM4, and the other one is a return traffic from 4 to 1, 2 to 4, and 4 to 1. So there are no services being inserted. Now I'm going to create the service and insert it. Redirect. So I just created the service. Now if I refresh the flow, you will now see that the traffic from VM1 first goes into another host. I mean, it can be a firewall or any appliance for that matter. And then from the firewall, it goes into the server. And same applies for VM2. So in this case, I'm using the dest IP as a matching condition. I'm saying any traffic going to the VM4, please route it through the firewall. So that is the condition I'm using. All right.
So what was that script what kind of script was it? Do you have like the actual script itself?
I can show you the script.
Yeah.
Shell script.
All right. This is a VTN. And here I have a flow filter on the vBridge. The flow filter allows you to do that dynamic ACL policies. So inside the flow filter, you match some condition. The condition will also be created on the controller. Let me give you a full view of
this was just a config script.
Yeah. So there is a flow list. A flow list stands for the condition. What condition you want to apply for the filter or ACL rule. So I'm saying IP destination address, anything that is going to the 20 network. And then I'm coming into the VTN and applying that the flow list using the name flow list any, and I'm saying action redirect. So redirect is going to give you that advantage of pushing out through some multiple services in line to the to the traffic. So I'm going to say redirect the destination to some virtual interface or virtual interface of the VTN.
That's fairly intuitive. Okay.
Yeah, and then once you push it out, then you have to bring it back to the VTN. So the traffic goes out into the firewall. Traffic will come out of the firewall. Once it comes out of the firewall, you have to put it back into the VTN, which is the regular path. So for that, I've used redirect to the vRouter interface. So this way, we can just lay out a drawing for the VTN, which we can do it from, like I said, the API or CLI and the web UI.
Is the most efficient way to do this through the CLI, or do you have like a wizard or something that can make it easier for people to do service, like on-demand service insertion and removal?
That's a point. We have an open API.
Okay.
So from that API, you can send the message to create a flow list.
Yeah, so we can script it that way. Yeah.
Yes.
Okay.
So that you can create a program that can do all these service insertions.
Curl and bash and you're done.
Perl and bash. That's not. No, I'm not learning those two. I got Python down already. All right. That's it.
Curl, command line.
He's back to command.exe over here.
Yeah, I got. Yeah.
So you can kick this off to any firewall you want.
Anything.
Right? Well, any service you want.
Any service, yes.
When it pops from the VTN into the service, you lose the visibility of it.
No, we do not lose the visibility. So what we let me show you the VTN view of the. So this is where the graphical, the GUI comes in handy. We will know where the traffic is going.
Okay.
Excuse me for this, but I'm going to display the map. Show, and this way, these are the V externals.
Okay.
These are the V bridges. I've created a policy to redirect the traffic from this V bridge to a firewall. So now what goes inside the firewall, you may send 100 packets. Maybe this guy filters and sends you 10 packets.
Yeah.
That's outside our boundary.
Yep.
But you don't see the connection from the firewall back into VTN.
I will show that. So this is the input interface of the firewall. I've just pushed it inside into the firewall. Now, the firewall spits out the traffic. Now I'm putting it back into the VTN. So now it is back into the VTN.
So it does see it all the way through.
Yeah, it goes all the way through to this. So here you can see it also helps you in visualizing what type of rules it's applying.
Yeah. Those are the flow entries, I assume it's actually putting in?
Yeah, they are using the open flow entries.
Yeah.
Matching on 2020-24. Dest IP is the matching condition for that flow rule.
Yeah.
So how are you tracking that it's made it through that flow? And this might be an ignorant question here, but so the idea is right. So you're tracking a destination or a source IP. It comes into your fabric. The fabric then says, okay, I need to send out the firewall. The firewall sends it back into the fabric. How does the fabric then not re-identify it as needing to hit that service again? Like, I mean, like what is your, or if you wanted to chain multiple services together, how do you identify this has gone through step 1 and now it's moving on to step 2 and step 3?
Okay.
Right, because that firewall's not going to change source and destination IP. It's just going to filter.
But it's the in and out of the firewall, though, right?
It's in through a different virtual bridge.
Yeah.
Is that what it is? And through a
Vlan
different
tag, right? So that's part of the tuple that it's matching on.
Yeah.
Right. To identify that flow.
You see, he has the redirect on the virtual bridge. So
yeah, you can do it on the virtual bridge, or you can do it on the external or router. It doesn't matter.
Show the other direction, so you go in one firewall interface and out the other. The firewall interfaces are going to be in different. You're going to do different.
And the return traffic.
Vlan ID is part of your flow tuple, right?
Yeah, the return traffic,
your,
which is
flow
from
entry.
server to client, it's direct server return. So we don't. It doesn't have to go through firewall. If you want, you can also push it back to the firewall.
This wouldn't work, by the way. But
Yeah,
okay.
so yeah, if it's a stateful firewall, that's broken. So, so you'd have to fix the other side of that communication at this point. Okay.
You need, well, if it's easiest if you create two different forwarding domains, like VRFs, and then you just link them through the firewall.
Yeah. So,
No, depending on the firewall, you can apply. You can create the policies here. So what I'm doing here is I'm doing a one-way redirection. If you want to do the return also
You'd
to
have
be
to-
redirected,
you'd have to do the same.
you just do the same thing
Got
for
it.
the return path. So which is not going to miss the states that.
Yeah.
so is the answer to his question that a part of the flow entry match is the VLAN tag, and so when it comes in the firewall and back out, it probably changes VLANs? Or am I wrong about that?
Change the VLAN. So I believe you said the firewall doesn't change source and dest IP and other. It is true. So depending. So what happens on the switch is the ingress of the switch is going to check the dest IP or dest MAC, which is going to be unchanged. So in the VTN, we are going to specify for this matching, push it out through this port of the switch. So that is what the switch is going to look at. It is not going to look at is there any changes. So the controller already knows how to route the packet.
Yeah.
It just sets the forwarding entries on the switch. Switch follows when you create the redirection. Controller, okay, now you have to go out to the firewall, come in. So go out through port 1, come into port 2, and then push it out through port 50 or something.
So what you're saying is that when the traffic comes back from the firewall, it's technically at that point almost a different flow. And I understand it's the same flow
It's a
from a
different
definition,
flow.
but it's a different flow in the sense
It's a different flow.
The switch is now looking at the ingress port being a different port, and it's making decisions.
Yeah,
based
so the
off of that.
port's a differentiator. It's a flow lit. It becomes it's not a flow. It's a flow lit. It's a part of a flow. It's, it's
There's
overflow
one
flow
other
lit.
thing you can do. In the match condition, you can specify to which ports it applies or does not apply.
Yeah. Okay, that makes sense.
So you can say this redirect rule applies to this IP, whatever, but not if it comes through that port.
Okay. Yeah.
Okay, thank you.
Good. Okay, so now I have inserted a service called a firewall. Now the firewall thinks, okay, I have, I think VM1 is sending the bad traffic or something. If you want to apply a policy, you go to a switch and configure the ACL rule to drop or deny some traffic based on IP or MAC address. Similarly, we can do the same thing over here. But the case I'm going to use is the source IP of VM1. I'm going to drop VM1 from accessing the server VM4. Allow VM2 continue access to the server. So in order to do that, I'm going to run the script, which is going to, I will show you what is done. So drop VM1. Now, if you go back to this console, you can see VM2 is continuing to have access to the server, whereas VM1 is stopped. There is no access to the server at all. So what happened here is I've applied a drop policy, a matching condition on source IP of VM1 and applied an action to drop the traffic at the ingress switch. So let me show on the UI what has happened. All right, on the UI. So this is, I believe, VM2 and this is VM1. So the traffic sent out from VM1 is being dropped at the, so the firewall is continuing to send the traffic back into the router, but the router has a drop action which is dropping the flow from the source VM1. I can show you the script also. All right, here there is a flow list that has an IP source address 10.10.10.1/32, which means that host only, right? And I'm going into the virtual router. I'm getting inside the virtual router and I'm saying match the flow list and action is to drop. So any packet coming from that source IP will be dropped. Is that clear? So now I'm going to allow access to the VM1. Once you allow the access, Now the VM1 is back, and he is able to access the server. All right, this is the first part of the service insertion. And the next, we will get into the service chaining, where I'm going to insert another service in line before reaching the server. I'm going to do the same traffic generation. So what I'm going to do now is, I'm enabling the service chaining. I mean, this is a script basically. And now let's look at the changes on the VTN. Now, the first packet goes into the firewall 1. And then from the firewall 1, it goes into the firewall 2, which can be another service, right? And then from the firewall 2, you go to the destination. So now we have more services in line to the traffic before reaching the server. So this is a part of the service chaining, stitching multiple services inside the VTN. Is that clear? Any questions?
So, kind of leading back to where we were just a moment ago. Mm-hmm. So you have a flow comes from your source to your destination, gets sent off to firewall 1, mm-hmm. and then that sends off to firewall 2. Does every flow have to match that? I mean, because the idea is there going to be differentiation? Is there going to be multi-use for that firewall? Mm-hmm. Am I going to be able to say this flow goes to the firewall, comes back in, and then to its destination, and this particular flow goes to that firewall, goes to another firewall, and then goes to its destination?
Exactly.
Are you able to separate those?
We can. So
okay.
The quick answer to that is, this is a VTN view. Mm-hmm. Inside the VTN, you can just see the flow inside the VTN, inside the VTN topology. Let us look into the physical topology. Maybe that will give you a better understanding before answering your question, right? All right. So here, I have the traffic going into the firewall 1, okay? Now, from the firewall, it goes into something called DPI, right? So what happens here is, this switch is having an ingress entry, and then egress is to the firewall. This firewall is sending again another ingress entry, egress entry. Again, it will send back ingress and egress. So there are 3 flows actually set up from the controller on the switches mm-hmm. to handle that one packet matching on some conditions. So I can also do one more thing, probably not for this demo, but it is possible to be done. So you can matching on the dest IP 20.20.24 and source IP 10.10.10.1, push it through two service. But source 10.10.10.2, just one service is good. So you can do that by applying the multiple conditions on the VTN.
Does this come back to the answer for the first question, the fact that it's based off of the ingress? So the idea is so that we're going to ingress on this interface coming from the VM. We're going to set off to firewall 1. Mm-hmm. Now, when it comes back from firewall 1, it comes back into your fabric. You say, okay, coming from fabric with the same rule applied, same source, same destination, that one gets sent off to firewall 2. Now, if you want a different policy for a different set of source and destinations on the ingress from firewall 1, yes. You say you don't have that same policy and off it goes to...
No, it might have another flow rule.
Right.
So the flow rule 1, for few matching condition, push it to firewall 2. Mm-hmm. Flow rule 2 on the switch, matching on these conditions, push it out through this port.
So the critical part in this, and this is how I'm understanding, is it is all based off of ingress interface or MAC address or whatever. So all these flows, they're not holistic in the sense that from source to destination is going to go from here, 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 and here. Although that's the end result. You're actually programming 3 or 4 unique flows every single time.
Unspecified the chain of services.
Right.
Let me understand what that...
Well, you see, ideally you would say flow from A to B has to go through firewall, IDS, and load balancer.
Okay.
What you have to do, because of the way the system is designed, is you have to specify 3 redirect rules.
Okay, that's right.
So you can't specify in one VTN rule the whole chain of services. Obviously, you could write an application on top of VTN that would do that, but that's a different story.
No, so why do we need, first of all, the requirement of a service chaining or a service insertion is to offload the traffic going into the firewall or other services. Am I correct?
Yeah, but there are two steps. Service insertion, yes, you do that. But it's one service. Service chaining would be like, I want to have these 5 services in a chain.
Okay.
Whereas you have to do 5 service insertions.
True. It's like stitching multiple services.
Yeah.
Like service chaining.
Yeah, so the orchestration of the network would be out on top of the product.
Yeah.
So we have OpenStack, we have SCVMM integration, and those.
You need another layer of abstraction. Yeah. Use your abstraction to implement service chaining.
Well, the important point is to have visibility across all the layers of abstraction, right?
Are we good? All right. Next part of the demo. I'm going to continue using the service chaining, and I'm going to migrate the VM4 from the host 2 to host 1. And my point is to show that the services applied to the VM will also be migrated to the end or the different host. So the traffic rule will not change. Let me do this VM migration. So currently it is configured on Windows 2, which is a second host, and I'm going to push it out through the host 1. Give it a few seconds, please. I have to wait for the stars to come up if I have to move it. So, okay, the migration is taking place. So let me show the flow. The traffic. So my point to show here is, after the migration happens, in between the final migration point, there will be a small traffic delay or traffic drop. But once the migration is completed, you will see the traffic comes up. So you can view it here. Let me. All right, the jobs are almost done. All right, so the job is done, and we can see that the traffic is back alive. And we almost, I don't know, we even saw any traffic delay. All right, let's look at the GUI, the web UI. All right. So the traffic from VM1 still goes into the firewall, and then from the firewall it goes into the next firewall or the next service, And from the next service, it goes into the VM4, which has been migrated from host 2 to host 1. So we still have the policies applied independent, no matter where the VM is. The policies will be applied based on the matching on dest IP, or it's basically a 12-tuple matching conditions. All right, are we good? So,
You want to show the API?
So yeah, one more quick question about your management console here, and it's been a recurring theme. We've asked this everywhere else. Is this HTML5 based, or is there something? What is your management? I guess is it HTML?
I believe it is HTML, right?
But the next question is, can I customize? Like, so I noticed when you come to that little home page, there's some options there. Can you customize it to where when you log in, you have like a different view? It's like, can I go straight to this page or something by any chance? If that seems to be the most useful for maybe day-to-day operations.
So you want to directly get into this?
Yeah, like when you log in, it can jump straight to that screen. Just
I believe after logging in, you will first see this window, and on the tab here, you click on the map and you visualize the map.
Oh, that's not too bad. There was something else that came up before, I thought, but okay. That was like 3 or 4 clicks to get there, but that's fine.
Oh, okay.
So yeah, you jump into here, yeah.
This one will give you. It is like a list view about what is happening on how many networks you have. It gives you, I have 4 OFS and 10 flows, 2 VTNs, and if there are any alarm messages, you will get those information here. So it is like just an index.
Yeah, so I guess the question is more like, do you have like a customizable dashboard? And it sounds like no, not really yet.
I believe this is...
No, we don't have right now.
Okay.
I believe it is not customizable.
Okay.
I think what you're looking for is like a dashboard.
Yeah, like a dashboard where I can say, yeah, I want the map to be also, when I have that, what you have there on the left, and then maybe the map on the right or something.
Now you just opened a nice can of worms. Thank you.
Great. I haven't started.
Something like role-based access control where I could only see my VTN or I could only see the physical network.
Yes. So you have a role-based control here. So you can create the users. So this can be done only by an administrator. So I have logged in as an administrator. So you have an account. So you can add a new account. And inside the new account, you can give them some privileges, what type of privilege you want to do. And it is also applied for the Linux. I mean, in a Linux environment, you also do the user level. That's also applied here. Any other questions before I hand it over to Toshal?
We were going to show API.
So I can show you a brief thing about the API. Collecting the logs. So what I've done here is the flow filter that I've created inside the VTN. I'm using an external API to collect the statistics from the flow filter. So PFC opens and gives you the information that you require, and this is the API rule. Like it says, inside the VTN, inside the vRouter, inside the flow filter of the vRouter, give me what is happening right now. So here, if you go and do some refresh, you can collect the traffic statistics. This can be very useful for a deep packet inspection or some services. We can open these services to them, and they can check if the packets are, good packet or bad packet, basically, and then do the redirection from the application to redirect it.
You have a slide to show, right?
Sorry?
Slide you had to show for that application traffic redirection.
Okay, so this is basically what it does. So the application will send an API call to the controller to get the traffic statistics, and it can get the traffic statistics based on some interface option. So creating the vlinks will require an interface on the virtual components. So from that virtual interface, the application is trying to collect some statistics. So this is a monitoring interface, bordered in red. And then the PFC or the controller will send the information, the response back to the application. And then the application will send a post API message to redirect through the DPI. And then once the message has been received by the PSC, the VTN changes and the packets go through the deep packet inspection. So this is how it works from the API. So if you are more interested in doing this application, HDN space, so we can contribute to the, we can jointly work on that.
So is that SDN space similar to like a pseudo GitHub repo where everybody's just kind of putting their configurations, or is it more, I assume it's more than just that?
Yeah,
maybe John can say.
So far, it's going to be use cases and you know, some of the integrations we've done with partners, but more and more we're going to be putting you know, validated use cases that you know, integrate both data plane and application into there.